Hello everyone and welcome you all for this video session on the topic the data preprocessing and the transformation, and the main topic which we'll be exploring today is dimensionality reduction. Myself Dr. Kondekar from Walchand Institute of Technology, Solapur. So let us try to understand what this dimensionality reduction is, what is the need of this dimensionality reduction, and then we will be talking about how exactly this dimensionality reduction can be done. Once you understand what is the need, what are the advantages of doing this dimensionality reduction, it will be quite interesting to learn how exactly this dimensionality reduction can be done. Remember, whenever you are giving the data as the input to any machine learning model, the data is many times not given as it is. The data is converted into its a feature vector. Many times when you are giving the image as the input for the machine learning model, remember, most of the times instead of image, what I do is I extract some useful attributes, we call it as useful features, and number of features are there for that data or for that image, we call it as there is a feature vector. So now if you have that large data set with too many attributes, so these high dimensional data sets or feature vectors will affect the performance of the machine learning model which is going to develop. So if you do the reduction in the dimensions, if you reduce number of features you are giving as the input to the machine learning model, okay, so then that will result into efficient development of the machine learning model. So this dimensionality reduction maintains the the attempt we will make is to maintain the important information from the original data set. Whatever is redundant, whatever is not required, whatever is the least significant information or least significant feature values, so those I want to remove from the data. So and then the dimensions will get reduced. So yes, once you know what this dimensionality reduction is, what are the benefits? What are the benefits of doing this dimensionality reduction? So these are some key points highlighted which are talking about the advantages of dimensionality reduction, where it reduces the time taken for developing that machine learning model. Dimensionality reduction reduces the memory usage, because higher the dimensions, higher storage you will require for storing those feature values. So because of this dimensional reduction, the performance of the machine learning model is improved. So whatever irrelevant values, noisy values are there, so those are getting eliminated. So a simple and efficient model, more interpretable model, machine learning model can be developed. And if you have this dimensional reduction, the visualization also can be simpler and effective and efficient. And this dimensionality reduction reduces the cost of the feature extraction also. So with these many benefits of dimensionality reduction, now it's interesting to learn how exactly the dimensionality reduction can be done, because there should be some rationale behind reducing the dimensions. I have input with 100 features I want to reduce it to 10. So it's not like just randomly you remove 90 and then what remains 10 I will be using. So there should be some rationale behind how you are reducing the dimensions of the data also. Basically there are two approaches used. So quite standard approaches is called as, first approach is called as attribute aggregation approach. And the second approach is called as attribute selection. So in attribute aggregation approach, what is done is the existing attributes are taken and then they are used to form some new attribute. Only thing is, existing 4-5 attributes I take and I form one new attribute. So for 5 attributes I am forming one new attribute, so number of attributes are getting reduced. So this approach is called as attribute aggregation approach. And another approach is just attribute selection approach. In that I have 100 attributes, I want 10, so I will take the decision which 90 attributes should not be present in the reduced dimensional data. Okay, so that is called as attribute selection approach. So remember, in attribute aggregation approach, a new attribute is been getting created. Only thing is that attribute is representing information present in more than one attributes. Okay, and in attribute selection, existing set is there. Out of the existing attributes, only few of the attributes will be used and few will be removed or will be deleted. So that is called as attribute selection approach. So these two quite standard approaches are used for dimensionality reduction. So when you go for the approach called as attribute aggregation, so again there are various methods of doing this attribute aggregation. Quite popular approach is called as principal component analysis. There is improved version of that, we call it as independent component analysis. Then there can be approach called as multidimensional scaling, and then lastly kernel PCA is also one approach of the technique called as dimensionality reduction via attribute aggregation. So here what is done, the key point is in the attribute aggregation, whatever data you have with multiple dimensions is projected into a lower dimensional space, right? The simple example may be a student having grades given for each and every course. For a semester, student is going for 5 different courses. I have 5 different attribute values. So then I use those 5 values and come up with one attribute called as average of these 5. Okay, and that attribute is representing the average of these 5. So I am, instead of 5 attribute values as the marks for individual course, I am using that average. So I am reducing the dimensions. So this is all about the technique of attribute aggregation via principal component analysis, where the projection is done. So there can be a linear, the new dimensional value may be a linear combination of the original dimensions. So the linearly projection of the data is taking place in fewer dimensions. This is the key of the principal component analysis. So a new variable is created, and to that variable we call it as principal components, and then they are ranked according to the variance. Next is independent component analysis. So the independent component analysis aims for separating the independent signals from the data. So here for example, if you have the voice input, and then what can be done is the separating the voice in the noisy room. So that is one good example. So you have noisy data. So what you want to separate out from that is the actual voice signal. So it is used in blind source separation, that independent component analysis. So basically what it does is it tries to find the components that are statistically independent with respect to each other. So when PCA is not performing well, then this ICA part is used when PCA does not capture that independent structures. So another technique may be multi-dimensional scaling, where the pairwise distances are used between the objects, and instead of the attribute values, those distances between the objects are considered, and it is used to project those objects into the lower dimensional space. So next approach is attribute selection. So as we talked about key attribute aggregation, the new attribute is created, but in attribute selection you have some attributes, you will decide which attributes will be there and which attributes will not be there. So when you are using this attribute selection, so there can be 2 different approaches used. One is called as forward selection, another is called as backward selection. Okay, so we'll talk about these techniques. So, and there are some standard attribute selection techniques like filters, wrappers. There is a technique called as embedded, and then there can be some different search strategies also used for this attribute selection. So let us try to understand this filter method. So in the filter method, what is done is what you do is you try to find out some relation. Maybe you have different attributes, and then what you do is you try to find out maybe correlation between those attribute values. Okay, and then find out the relationship between the attribute values, correlation between the attributes, and correlation between individual attribute and the target. Now see, if you find that the correlation between a particular attribute and target is higher, then that attribute is playing important role in taking the decision or making the decisions. Okay, if you have two attributes and then you find that those two attributes itself are highly correlated, in that case I can think of using one attribute and removing other one, because already they are highly correlated, the same information you have. So what can be done is you can find out those relationships, you can rank those attributes according to those relationships, and then let us say I have 5 attributes and then I want to choose 3 attributes out of that. So what approach can be done? You calculate the correlation between each of the attribute and the target. Okay, and then whatever correlation values, you arrange those attributes in the form of descending values of the correlation, and top 3 highly correlated values you will use, remaining 2 you will neglect. So this is the rationale behind removing the attributes. So ranking is done, the correlation information gain can be used for deciding which attribute is to be kept as it is and which attribute is to be removed. So like that, there can be approach called as a wrapper method, where the different predictive models are used, and then what is done is the some set of attributes are taken, a model is developed, its performance is evaluated. Okay, then different set is used, again the model is developed, its performance is evaluated, and for the set for which you find higher performance, okay, so that set of attributes you will consider, and remaining attributes you will neglect. So one approach may be forward selection and backward selection, or backward elimination we call it as. So another approach is called as embedded method. So here the attribute selection is done by using the model training. So decision tree regression models are developed, and then this embedded approach is more efficient as compared to the approach called as wrapper. So there can be some search strategies used. So forward selection, backward elimination. In forward selection is like you take an attribute, you evaluate the performance, then you add one more attribute, you evaluate the performance, you find that the performance is improved, keep that attribute as it is, if not, remove that. So like that you go on adding, and then the attributes which are resulting into the improved performance of the model are kept, other attributes are removed. Backward elimination is like you take all the attributes, you calculate the performance, you remove one, check the performance is improved or degraded. If the performance is improved by removing, so eliminate that. So, and if you find that performance is getting degraded, keep that, you go on removing the next attribute. So like that, this is called as backward elimination. So in forward selection, you start with the one attribute, you go on adding the attributes which are useful. Okay, and in elimination approach, you consider all the attributes and then go on eliminating the attributes which are least significant. So the exhaustive search strategies may be used, heuristic, meta-heuristic search algorithms may be used for deciding which attributes are playing significant role in deciding the output, and those attributes can be kept, and the dimensionality reduction will be done with this approach. So summarizing the things, dimensionality reduction is essential, because many times you have the data with the higher dimensional data increases the complexity of the machine learning model which is developed. So two approaches, one is called as attribute aggregation, another is called as attribute selection approach. Aggregation can be done by using different techniques, maybe PCA, ICA, MDS, and then attribute selection also approach has different methods, like it starts with filters, wrappers, embedded methods, and then this dimensionality reduction definitely helps in improving the performance of the machine learning model developed. It improves the interpretability, and if you are trying to visualize the data, if you have reduced dimensional data, so visualization is also more effective. and impactful. So these are the various references used for this video presentation. Thank you.